Hello everyone, this is Mrs. Kulkarni, lecturer, Department of Physics, KLS Kokte PU College, Belgavi. In continuation with my earlier video on motion in a plane, that is 4th chapter, and this is my second lecture from the same chapter. In the last video, I discussed some important concepts based on scalars and vectors. What is a scalar, what is vector, examples, everything we discussed. In this video, I am going to discuss in detail about this vector. So vectors, scalars and vectors are very important concepts in physics. If we understand them properly, then it is easy for us to solve many problems, okay, or we can understand the higher level questions in which are asked in NEET, JEE and CET. So vector is nothing but what? It is having the magnitude and as well as direction. Such physical quantities are called vector quantities. Apart from that, vectors or the physical quantities have to obey some vector rules. So this is very important point. The next one, define notation of vector. How we have to define or how we have to represent the vector? By using this type of arrow, okay. So this is the notation for the vector. A vector quantity is denoted by a small arrow above the physical quantity, okay. Suppose if we are writing a velocity in the vector form, then we have to show this arrow on the top of the physical quantity. So here I just shown some example. Suppose a vector quantity A. Suppose A is a vector quantity. If we are writing this A in the vector form, then how we have to write that vector form? So in this way, okay. So vector A. This is the procedure. This is the procedure of writing the vector quantity. Few more examples I shown here. Displacement and velocity. So S is the notation for the displacement. Suppose if we are expressing the displacement and velocity in the vector form, then how we have to write? This S is a displacement notation and V is a velocity notation. So this is the procedure of writing the vector quantity, okay. So how we have to read that physical quantity? Vector S or vector V. In this way we have to read the vector physical quantities, okay. So physical quantities, if they are in vector form, then we have to read in this way. Next one, magnitude of vector notation. If a vector quantity is A, suppose you assume that if a vector quantity is A, okay, then the magnitude of vector is written as, how we have to write the magnitude? Using the parallel lines. So suppose A is a vector, then we have to write the magnitude notation. By using the two parallel lines, we have to write the magnitude of vector A. This is the procedure of writing, okay. Few more examples I had taken here. Magnitude of displacement. Displacement is a vector quantity, so the notation for displacement is S, is written as. How we have to write that one? We have to write this by using the parallel lines along with vector symbol, okay. Similarly for V, velocity, magnitude of velocity is written by using two parallel lines and this vector symbol. But what is the answer? Magnitude of vector S is nothing but S only, displacement only. If we decorate or if we put some jewelry on this, then the physical quantity will not change, it remains same, okay. So you assume that these are the jewelry for this vector quantity, okay. So two parallel lines indicating what? They indicating the magnitude, okay. So these two parallel lines are nothing but why we have to draw these two lines? If we are writing the magnitude word, suppose if we are mentioning the magnitude, then that time we require these two parallel lines, okay. So symbolically we have to write like this. These are the notations for the magnitude and this is the vectors notation. So value will not change, value remains same. Only thing, we are expressing in the notation form. Okay. The next, vectors can be represented by two ways. So vectors can be represented in two ways. So what are those two ways? One is pictorial form, another one is equation form. First one, pictorial, means in the form of picture or else in the form of equation. So vectors always represents in two different forms or two ways. One is pictorial, another one is equation. Let us understand first what is pictorial. Pictorial means, suppose if we want to say vector, the force of vector or a force is somewhere around 10 Newton. Okay, this is a pictorial notation. This arrow is nothing but what? It shows the pictorial notation. Okay, this arrow is nothing but pictorial. Force on the object is 10 Newton. Then we have to mention the, where is the force? We don't know the force. Or else suppose the force of the force on the object is 10 Newton in the north direction. Then how we will show? In this way. Okay, so this is what? Pictorial notation. In the picture form or in the form of a drawing, we show the vector. This is a one procedure. Then what is this 10? 10 is nothing but magnitude. 10 is nothing but what? Magnitude. N is Newton. So this is nothing but, it is a unit. So 10 Newton means it is magnitude and this is unit. Okay. Then how we express that vector A in the notation form? So magnitude means two parallel lines. Okay, magnitude of vector A. This is the notation which we use to write the magnitude of vector A. Suppose if we want to express the vector in the equation form, then vector A is equal to vector A into A cap. What is this A cap? A cap is a unit vector. I am going to discuss in detail about this unit vector in the next slide. Let us understand only first what is pictorial form, what is equation form. Okay. So this, is it not equation? This is one type of equation. Magnitude is equal to square root of p square plus q square. So we are expressing these vectors in the equation form, or vector A is equal to vector Ax plus Ay. All these are vectors. Okay. So is it not in the equation form? So these are in the equation form. Along with this, we have to write here I cap. This is I cap, and this is j cap. Why I cap and j cap? That also I am going to discuss in the next slide. So always you have to remember, equation form of vector is always expressed in unit vector form. So this is very, very important. Whenever we express the vector in the equation form, then we express along with the equation, we express unit vector, or we express that expression in the unit vector form. Just now I expressed no Axi, Ay, j cap. So here also it is A cap. So that is unit vector. Okay. Next one, displacement vector. This is one example here. Suppose a person wants to move from his house to college. Is it not this path? So he is moving from his house to college in this way. Is it not displacement? The person is displaced from his house to college. So that is called displacement. That displacement is denoted by d. Here I had taken the notation d. So suppose if he selects different path, instead of going in this way, suppose if the person wants to go in this way, then reaches the college. This is another path which he selected. So this is also possible. This is one path, this is another path. Okay, both are displacement only. Okay, finally he reaches where? To his destiny, either by selecting this path or by selecting this path. Okay, so both are displacement. So suppose this line is x-axis, this is y-axis because it is a vertical and this is a horizontal. So I can say this is the x-axis and this is y-axis. So the displacement along x-axis I denote by dx. The displacement along y-axis is dy. This line is vertical line, this is which is opposite to this y-axis. So that is the reason this is also dy. Both are displacement. This is also displacement, means one vector is splitted into two different constituent components. Okay. So we can write the expression in this way. The total displacement d is equal to dxi cap and dy j cap, and I j are what? They are unit vectors. Okay. So next one, position vector. It is a vector drawn from the origin. So we have to remember what is position vector. It is a vector drawn from the origin of the coordinate system to the position of the particle at any instant. It is a vector drawn from the origin. Origin means what? Suppose if we draw two dimension, because we are discussing here 2D. So this is x-axis, this is x-axis and this is y-axis. If we draw one line from this origin, okay, if we draw the lines like this, then we say that position vector. Okay, origin of the coordinate system to the position of the particle at any instant. If we are drawing like this at any direction, then they are called what? Position vector. Then some important points which you have to remember. Number one, it helps to locate the position of the particle moving in a plane. It gives the direction of the position of the particle with respect to origin. It gives the straight line distance of the particle from the origin. Okay, so these 3 points we have to remember. Next one, unit vector. So in the previous slide many times I used unit vector. Then what is unit vector? In the last video also we discussed the definition of the unit vector. A vector which is having a magnitude 1 or unity, that is called a unit vector. Of course we can define easily, but we have to understand what is the importance, why we use this unit vector frequently in the equation whenever we write the vector in the equation form. That is very, very important. Unit vector is the vector represents the direction of the vector. This is very, very important. It shows what? Direction of the vector. So what is vector? We know vector is nothing but what? Magnitude and direction. Vector is nothing but what? Having both magnitude and direction. Suppose A is a vector, A is a vector, okay, then vector A is equal to magnitude of vector and this is A cap. A cap is what? It is a direction. So vector A is equal to magnitude of vector A into A cap. A cap is nothing but it is a direction. This is a magnitude and this is the direction. So that is nothing but product of these two is nothing but vector. So where this A is vector, okay, and magnitude of vector A, okay, and A cap is what? A cap is the direction of vector A. Okay, so this is about the unit vector. So in detail let us study. Okay, suppose how we have to write the unit vector in the equation form. A cap is equal to same this expression only. We are going to rewrite the same expression in this way. A cap, take this magnitude of vector A towards this side, means like this. Okay, then shall I write like this? Unit vector A cap is equal to vector A divided by magnitude of vector A. So this is an expression for what? Expression for the unit vector. What is the meaning of this equation? I will show you one simple example. Suppose vector A is having a 10 Newton force. Okay. A is how much? A is 10 Newton force. What is A by 2? Is it not 5 Newton force? Okay. If we divide this force in two parts, is it not 5 Newton? Okay. Directions are same. Direction is same. Okay. But if we divide or if we break this vector in two parts, then is it not A by 2? A by 2 means nothing but what? Is it not 5 Newton? Means 10 by 2. 10 by 2 is equal to, why 10 by 2? Because A is equal to 10 Newton. So then 10 divided by 2 is it equal to 5 Newton. So force is 5 Newton. You just assume, okay. So if we apply 10 Newton of force, or if I substitute this value in this expression, then what is my unit vector? Vector A is 10 here, magnitude of vector A is also 10. Am I correct? So A cap is equal to 10 divided by 10. Is it not 1 Newton? Okay. The meaning of this expression is what? 10 by 10. That is nothing but 1 Newton. So what is 1? 1 is unit. Okay. So unit vector. I hope you understood this. This is very simple. Okay. In understanding, the concepts are very simple, but they are very important in the physics. If we understand scalars and vectors properly, thoroughly, then we can solve any type of problems. Okay. So A cap is nothing but it is a unit vector. Okay. Next one, I just taken few examples here. You assume that, okay, suppose this is a rectangular box or your mobile phone. Okay. So one person is applying force in this way along x-axis, and what is the force? He applying the force somewhere around 10 Newton in this direction. Another person applying the force on the same mobile in the vertical direction, and that force is also 10 Newton. So both forces are 10 Newton, but here the directions are in this way. Okay, one person is applying the force in this way, another person is exactly perpendicular to the previous one. Okay, so what is the angle between these two? Is it not 90 degree? Definitely 90 degree. Then where is the mobile phone? Where it goes? Definitely the mobile phone will not move either like this or like this. You try it in the home. This is very simple experiment. The mobile phone always, or the object always moves along the bisector or along in this direction, or diagonally it will move. This is very important. So the object will move along this direction or along bisector at a 45 degree angle. Okay, that is very important. By 45 degree bisector, because we know that bisector, we are talking about the bisector. So here the angle between these two is 90 degree. Definitely the diagonal or this bisector angle is 45 degree. Okay, so this you have to remember always. Okay, whenever you apply the force along x-axis and y-axis, okay, in this way, then the object will not move either like this or like this. Always it will move diagonally. This is very important point. Okay, so immediately we have to join the or complete the rectangular by joining the two sides. So this completes a rectangular. Then here I just written 10 square root of 2. Why like this? When we complete this rectangular, is it not one triangle? Is it not this is triangle? If this is 10, okay, this is also 10. If this is 10, this is also 10. So this is right angle triangle. Apply the Pythagoras theorem. 10 square plus 10 square, okay, is equal to how much? 100 plus 100. Okay, then is it not 10 root 2? Okay, so that's the reason diagonal value is 10 root 2. Okay, I hope you understood this diagram. And here in the equation form I just written the same vector 10 I cap 10 j cap. I and j are what? Unit vectors. Of course the value of I and j is 1, but why we use? Because for the direction purpose. Okay, so F net force is equal to 10 I with respect to this 10 I, and 10 I is equal to how much it is? 10 root 2. Suppose if the force, applied force, if the same object, if we consider the object here or a mobile phone, if the force applied on this is a diagonal at 60 degree, okay, suppose you assume that this is one example, this is another example I just shown, okay, this is a 90 degree angle between these two is 90 degree. The question arises immediately, some students may ask, suppose if the object moves in this way, okay, then how we have to, or the object is moving at 60 degree angle, okay, the angle between these two is 60 degree, okay, this is 10 Newton along this direction, this is 10 Newton along this direction, and angle between them is 60 degree. In this case, can we draw a rectangle? No, not possible. Or can we draw the diagonal? Yes, it is possible. We can draw the diagonal. So we can draw the diagonal at 30 degree. The angle between these two is 30 degree. Okay. So always diagonal is at bisector. This you have to remember. The object will start moving in this direction, in this way, at angle 30 degree. Okay. So the object will not go either like this or like this. The object will move in this way at 30 degree angle. Okay. Then can we draw or can we draw the rectangle here? Is it possible? No. In this case, we can't draw a rectangle. So instead of rectangle, we have to join the lines to complete the parallelogram. So this diagram is nothing but parallelogram. Okay. So this is another example. The next question arises immediately. What are the properties of the vector if the 3D object, if we consider, if we apply the forces in the three directions, in a 3D, three different directions, can we draw the diagonal? Yes, possible. For the cuboid, we can say the resultant vector is at cuboid. Okay, cuboid diagonal. So in the previous case, it was the resultant vector at diagonal, and in the 3D also we can draw the resultant vector at a diagonal point only, here or here or here we can draw the resultant vector. Okay. So always the object will move. Suppose if we keep one object here, then the object will move diagonally or at bisector. Okay. Next one, how to represent 2D vectors in form of unit vector. This is very interesting concept. So we are breaking one vector into two constituent vectors or components. Okay, so we can say that this is a vector v, this is vector what, v. So at angle theta, this is angle theta. Suppose if we can say this is vector v at angle theta. Okay, now what is our aim now? We are breaking, this is only diagonal. So the question arises immediately, can we draw the triangle or rectangle by using a diagonal? Yes, it is possible. Using only one diagonal we can draw a rectangle. Okay, so in the previous case, by using the rectangle we understood where is the resultant vector. By using one resultant vector we can study constituent components, means we are breaking this vector into its two components. Okay, how it is possible? So we can say that this is at a particular angle theta, so this is called cosine stick rule. So I think you might have studied in the school level cosine stick rule. So if suppose if this is going beyond this x-axis, okay, going beyond this, then we can say that it is v cos theta. And this vertical line, suppose if we join the vertical line, that is called v sin theta. So this is v cos theta according to what? According to the cosine stick rule. So v is a vector. Okay, suppose if we are applying cosine stick rule, then it will be v cos theta along x axis, along y axis it will be v sin theta. This you have to remember. Or this is a vertical component, this is horizontal component. For a horizontal component v cos theta, for vertical component v sin theta. So vector v, this diagonal or this resultant vector is splitted into constituent components. Okay, and we are expressing in the unit vector form. Okay, then immediately join these lines. Is it not rectangle? By using only one diagonal resultant or bisector, we have drawn the complete rectangle in this way. So we can break one vector into two components, or by using two components. So here in the previous case what we studied, using two components, using these two components we can draw resultant vector or a diagonal or a bisector. Okay, so this is by using two components we have drawn diagonal or the resultant. Okay, in this case using diagonal or the resultant vector we have drawn the complete rectangle. Okay, the next one is the same example I have shown separately here along x axis and y axis separately. So same, assume that this is a vector A at angle theta and this is splitted into two components. So along x axis A1 cos theta, along y axis A2 cos theta. Why it is y? Because it is a vertical component which is parallel to y axis. So A2 sin theta. Okay, A is a main vector. So A is equal to A1 plus A2. So A1 is along x axis. So that is the reason I cap is nothing but this is unit vector, and A2 is along y axis. So j cap. Okay, I, j are what? They are I, j, k. All these three notations are nothing but what? They are for the unit vectors. Of course value is 1. Why we study unit vector? To understand the direction. Okay, so along x axis this vector is A1 cos theta, or you can say A cos theta also, no problem. Okay, so along this y axis A sin theta. So I just rewrite the same expression in this way. because to understand what is cos theta and sin theta, I had written the same equation in the different way. Cos theta is equal to a1 divided by a. So this cos theta is equal to what? Same expression I had written like this, a1 divided by a. The same expression sin theta is equal to a2 by a. Okay. Then next we can express in this way also, a1 is equal to a cos theta I cap, a2 is equal to a sin theta j cap. Okay. So this is about the vectors in the pictorial form and equation form, and if it is in the equation form, we usually mention or we have to express that equation vector form in the unit vector form. This is very important point which we have to remember. Okay. I hope you understood all the concepts properly. If you want further questions and answers from the 4th chapter, please go through this website link. Okay. So which will help you to know more questions and answers from the 4th chapter. Thank you.